Hello everyone. In the previous videos, we have discussed in detail about the hybridization in alkenes and alkene system. In this video, we'll discuss about the hybridization in alkyne system. So the general formula for alkynes is CnH2n-2. Each carbon atoms are attached to two more atoms. So if you look at the electronic configuration of carbon atom in ground state, it has 1s2, 2s2, 2p2 arrangement. So when the energy is absorbed by the molecule either in the form of heat or light, the electron in 2s orbital is promoted to the higher energy level, that is 2p orbital. So one of the electron is excited to 2p orbital. One of the electron in 2s orbital is excited to 2p orbital. So here carbon is going to combine with two more atoms. Hence it needs mixing up of 2s and one of the 2p orbital. Since two atomic orbitals are mixed up, so it will generate 2sp hybridized orbital. And when these hybridized lobes tries to lie far away from each other, that leads to this geometry in which the angle between these two lobes is going to be 180 degree. Remember that you have two unpaired electrons now. So one unpaired electron is lying on 2py orbital, the other one is on 2pz orbital. So both are perpendicular to each other. So this is how the lobes will look like. One of the lobe on sp hybridized orbital will combine with 1s orbital of hydrogen atom and forms a sigma bond. The other lobe will combine with another sp hybridized carbon atom and generates a sigma bond. Now we have two more unpaired electron on 2py and 2pz orbitals. Both are perpendicular to each other. This will involve in pi bond formation. See here, this picture exactly shows how the sideways overlap occurs by the sideways overlap of unhybridized 2p orbitals. So these two will combine together. These two will involve in sideways overlap and the other one. So there is possibility of the generation of two pi bonds here. So this is the bonding in ethyne, that is acetylene. So the angle between hydrogen, carbon and carbon is 180 degree. And the bond length of carbon and hydrogen bond is 1.09 Armstrong, as we have discussed in the earlier case. But the distance between the carbon and carbon is much more shorter than alkenes. It's just 1.20 Armstrong in this case. The carbon-carbon bond length is 1.20 Armstrong, which is much more shorter than alkene because it has two pi bonds in it. So this is how sp hybridization results in alkynes, and this makes the alkyne molecule linear in geometry. So thank you for watching. Happy learning.